Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, today let us discuss about definition and terminologies and a number of problems related to structures and union concept in C language. So, let us start with the definition of structure. Now, what is a structure? A structure is a user-defined data type used in C language that allows you to combine data of different type. And the structures are in real time, it represents a record. And to define a structure, we will use the struct keyword in C language, and let us have a look at the format for writing a structure. So to write a structure, we have to use the keyword struct followed by you have to give a user defined structure name, and the structure name also follows the rules of identifier. Now you can define a number of members inside the structure, and all the members can be of different types. So the collection of members are always of heterogeneous type. So you can define each member, and at the end of the structure, the members of the structures are enclosed in the parenthesis, and at the end you have to provide a semicolon which says that it is the closing of the structure. That means a structure has been defined properly. So this syntax you have to follow while declaring a structure. So struct is a keyword over here. Now let us see how to declare a union. Now coming to union is also a special type of data type in C language which stores different types of data or heterogeneous collection of data types. But the difference is it refers to that means all the members of the union must share the same memory location. So in structures, all the members will have their own memory location, but in union, all the members need to share the same memory location. That is the difference. Now, we can define a union with multiple members, but only one member at a time can access to that memory location. And unions provides an efficient way of using the same memory location for multiple purposes. So wherever in any application you need to share the memory, you need to share the memory for saving purpose, then you can go for an union. For example, if a person has a permanent address and a present address, but a person needs to use only one of the address at a time, then instead of declaring the present address and permanent address inside a structure, you can go for declaring present and permanent address inside an union, and one at a time you can use it. That means either the person has to use present address, otherwise the person has to use the permanent address. So in this way you can save memory also. So how to declare an union? So to declare an union, you must use the union keyword. So the format for declaring a structure and union is almost similar, only there is a difference in the keyword. So let us see how to write an union. So union followed by write an union name. Union names are nothing but the user defined names which also follows the rules of identifier. Now inside the parenthesis, a number of union members of different types can be declared, and at the end you have to provide a semicolon which indicates that union declaration is completed over here. So this is the way you have to declare a union. So to declare a union and a structure, struct and union, two different keywords are available in C language. Now let us talk about what are the similarities are there between a structure and union. Now let us talk about the similarities between structure and union. Now both are user defined data types used to store data elements or data types of different nature, or a collection of heterogeneous data types can be combined and used as a single unit in both structure and union. So this is the first similarity. The second similarity is their members can be of any type, but one of the member or a member can also consist of a bit field. So the concept of bit field, that is to again save the memory, you can also represent that a particular member takes exactly how many bits of memory. So if you want to provide a bit field, then you can use it in both structures and unions. And in both structures and unions, they support assignment operator and size of operator. So you can assign the structure, one structure variable to another variable. Also, you can check the size of the structure variables. Next, a structure or a union can be passed by value to functions and returned by value to functions. Okay, returned by value by the functions. So you can pass a structure as an argument to a function. Similarly, you can pass also a union to a function, and also a function can return also. So the arguments must have the same type as the function parameters. Now the popular operators. Next, the popular operator dot operator is used for accessing the members of structure and union. So normally, two types of operators are used to access the members of structure and union. One is called dot operator, another one is called arrow operator. When the structure member is a simple variable, then we will use the dot operator to access the member. When the operator is a pointer type, then we will use the arrow operator to access its member. So dot operator is commonly used in both structures and unions. Now, let us talk about what are the differences between structure and union. Now, coming to the differences, we can differentiate between a structure and union based on a number of categories. First, based on the keyword. If you come to the keyword, then the struct keyword is used to define a structure, whereas a union keyword is used to define a union. This is the first difference. Second thing is, in terms of size, you can differentiate a structure and a union. So the structures, the size of the structure, if you want to find out, then it is a combination of the memory requirement of all the members, because every member will have their dedicated memory. So if you add it up, the complete or total memory requirement of a structure, then that is the total size of the structure. So we can also say size of the structure is nothing but the sum of sizes of all its members. But this is not the case in case of union. In case of union, the size of a union is equal to the size of its largest member. That means any member who has the largest memory allocation or largest memory requirement, that much memory will be allocated to a union, and all the remaining members has to share the memory location. So that's why the size of union is equal to the size of its largest member. But whereas the size of the structure is nothing but the sum of sizes of all its members. Third difference is in terms of memory. Between a structure and union, third difference is in terms of memory. So the memory requirement for a structure is more than in a union, because every member will have their own memory location. So each member within a structure is assigned unique storage area of location. So there is no sharing among the members in terms of memory. But in case of union, the memory which is allocated is shared by individual members of the union. Now, the next difference is value altering. So that means if you will try to alter the value of any member, any structure member, then it will not have any effect on the other members of the structure. So whenever you want to change the or alter the value of any member in structure, you can do it, and it will not have any effect to the other members. But whereas in case of union, as the memory is shared by all the members, altering the value of any member will alter the member value. So you need to be careful while altering the values for any union member. Next is accessing the members. How will you access the members of a structure? Individual members can be accessed at a time. That is in case of structure. So But in case of union, only one member can be accessed at a time. That is the another biggest difference. So here individual members can be accessed at any time, and here only one member can be accessed at a time. Now how to do? Last difference is how to do initialization of the members. So several members of the structure can be initialized at once. In one line, you can initialize all the members of the structure. But whereas in case of union, only the first member of the union can be initialized. Though you will try to initialize all the members, but it won't give you any error. But when you will print it and check, then you will see that only the first member will be initialized with the values. So, whatever the differences we have discussed in structure and union, now let us write a program and understand step by step that how a structure works, how a union works, and how to identify the differences between the structure and union. So, let us move on to the Dev C++ compiler and start writing a program on structures and unions. Now, we have shifted to Dev C++ compiler. Let us start writing a program to illustrate the difference between structure and union. So for that, let us first write down the header file. So hash include stdio.h. Now, to understand the differences, first we have to create a structure and we have to create a union first. So first let us create a structure. So to create a structure, we have to use the keyword struct. Okay, struct. Let us take struct example. And the members of the structure must be declared inside it. So let us take one integer member, one float member, and one character or string member. So for that, for declaring an integer, let us take integer. One integer member I have taken. Then one float member I have to take. Suppose the float member I am taking as decimal. And one character name I am declaring of size 20. So I have declared a structure. Now similar way, I have to declare a union also. So for declaring a union, we will use the keyword union followed by a union name we have to give. So let me write union example. Okay. Now let us declare the members of the union. Let us take the same members, one integer member, one float member, and one string type or string member. So let us write the same example I am using over here. I am writing the same member so that it is easy to differentiate between a structure and a union. And character name of size 20. Now give a semicolon at the end of declaration. So we have declared a structure and also we have declared a union. Okay. Now let us start writing our main program. Let us take void main, or you can write int main, and write down the program. Now to access the structure members or union members, we have to first declare the structure variable or union variable. So how to declare the structure variable? So for that we have to write struct followed by structure name. So struct underscore example is the name of the structure. So I'm giving a variable name as S. Okay. Now similarly for union, create a union variable. Union, the name of the union is union underscore example, and take a variable U. And let us first understand how to initialize the members of the structure. So let me write a command line here. So initialize the members of the structure and union. So to understand the concept, let us directly initialize with flower braces. Okay. Now let us take some values. So first member is an integer. Let us take 18. Then the second member is 38. You can take 38.5 or 2 or anything. Otherwise it will take 38.0 automatically. And then I am writing one name as IARE. Okay. Similarly, I am doing the same kind of initialization for a union member also. So here also I am taking that 18 as an integer, 38 as a decimal value, and a name as IARE. So here we have declared one structure and one union variable we have created, and we have assigned the values to structure and union. Now let us print these values and see that whether the initialization has taken place for all the members or not. So first of all, print the structure members. So let us write a message, structure members. How to print? Let us write a printf statement. Inside this, how many members are there? 3 members are there. First member is integer type, so percentile D. Second member is your decimal type, so percentile. So 0.2f after decimal up to 2 places I want to go for. And the third member is percentile S. Okay. So if you want to give, like I want to write integer is equal to this much, then your slash n, then decimal is equal to this one, 0.2f, and then name is equal to percentile S. So I have written the control characters, then followed by you have to write down the members. So how to access the members? To access the members, dot operator is required. So what is the name of the structure variable? S. Dot. Which member we are talking about? We are talking about integer. So you can select over here integer. Then what is the second member? S dot decimal. You can select this, and the third member is S dot name. So this is the way we can print. Then followed by, let us print the members of the union also. So let us write a similar statement. Printf union members. So how to print the union members? In the similar nature we will print it. So let us write a printf statement. So first member is integer. Integer is equal to percentile D, then followed by slash n, then our decimal. Second member is after 0.2f I am writing after decimal up to 2 places, 0.2 percentile f. Here we have to write percentile 0.2f. Okay. And the third member is a name. Name is percentile S. And how to access the members? Through dot operator. That is the similarity, you know that. So u dot first member is integer. Okay. Next u dot decimal. Then u dot name. Okay. 3 members we have written. And let us put the semicolon. So let us save the program and let us run the program first to see the output of this program. So you can see over here, we have declared one structure, one union, followed by we have initialized and we have created a structure variable and initialized all the members. We have created a union variable and also initialized all the members, followed by we have printed the structure. We have printed the structure members and your union members. Now let us save it, then go to compile and run the program. Now let us have a look what you are getting here. What are the structure members? 18, 38.00 after decimal 2 places we have told. Then name is IARE. Now coming to union members, integer 18 is coming, but the other 2 members are not initialized because the difference is in case of union only the first member will get initialized. So what is the highest memory requirement for the union? It is the 20 bytes. So the highest memory requirement is by the name member, which requires 20 bytes. So 20 bytes of memory space will be allocated to union, but one member at a time can use it. So whenever you try to initialize with multiple members, only the first member will be initialized. So after knowing about this concept, let us go for printing the other details like how to find out the size of the structure and the size of the union. Now, let us print the size of the structure. So, let me write just a new line character over here to give proper spacing. Okay. And here also I'll write a new line character to see proper spacing. Okay. Now let us print what is the memory requirement for a structure and what is the memory requirement for a union. So let us write printf /n size of structure. What is the size of structure? Is %d, which is an integer. So you know that in structure we can use size of operator, and the representative of the structure is the structure variable s. So we have to simply write s, size of s. Similarly, what is the size of union? So we can write size of union. Size of union is also an integer number. So we can use the size of operator. So you have to write size of union. Okay. Now let us save the program and run it again. So you can see over here, what is the size of the structure that is displayed? It is 28 bytes. Whereas the size of union is only 20 bytes. Because the highest memory requirement for any member of the union is 20 bytes. So 20 bytes is the space that is allocated and it is shared by all the members. So we have seen this size or the memory requirement of the structure and union. Now next what we will do, next we will try to access one member at a time and we will try to modify it. So let us write a printf for giving the proper spacing. Okay. Now try to modify or access every member and try to modify it. So let us write printf accessing one member at a time in structure. Okay. So how to do that? So for accessing each member, we have to use the structure variable dot the member name. So let us write the member name is integer and I am trying to modify. Earlier it was 18. Now I want to make it 100. Okay. And then try to access the second member is decimal. Earlier it was 38. Now I'll make it 50. Okay. And the third member is a string. So how will you modify a string? For that you have to write down the function strcpy string copy followed by write s dot name. Okay. Comma. What is the name you want to change? I want to change it to IARE college. Okay. Now all the members I have accessed one by one and then modified its values. Now let us go for the same printing statement which we have used over here. So let us copy this statement and print it over here so that we can display the content of the structure. Okay. So now let us do the same thing for a union. Try to access each member at a time and modify its value and then print it. So let us write printf. So I'm giving a spacing over here /n. Okay. Now I'll copy these statements and I will try to modify over here. So what I am going to change? Accessing one member at a time in union. Okay. Now here I am changing it to some 100, 50 and s dot name is equal to, I will make it to u dot name because the variable name is u dot name. So u dot integer, u dot decimal and u dot name is equal to IARE college. Now let us print the union. So we have already printed over here. Let us copy this, Control C and let us paste it over here. Okay. Now let us save our program and let us check the output. Now have a look. Initially the structure members, the first member was containing 18, 38 and name was IARE. Then union, one member only, the first member was initialized, the output was 18. Now the size of the structure was 28, size of the union is only 20 bytes. Then you are accessing the members of the structure, you have modified the value. So integer has changed to 100, decimal has changed to 50 and name has changed to IARE college, because every member has their own memory location. So whenever you will try to modify any member's value, it won't affect the other members. Now, the same thing will not happen for union. So in union, you can see that the integer, the decimal, that you have got some garbage. Okay, you have tried to modify one member at a time, but they all are sharing the same memory location. So the last member which you have modified, that is the name, that is the final value that is there in the memory. So when you are printing at a time, then only the last name is available in the memory location. So how will you use the memory? So whenever you want to use the memory in case of union, then after modifying the value, you have to immediately print it. Then only you can see the difference. Now try to again access one member at a time. Okay. Now let us write a printf statement /n printf modifying one member at a time in an union. In case of structure, this problem will not arise, but in case of union, this problem will arise. So what you will do? You will do u dot integer is equal to some 100 I have changed. Let us take it to 200. Then immediately you print this member's value. So you have to write your u dot integer or integer is equal to percentile d comma u dot integer. Similarly, u dot your decimal, you change it to any value, let us say it is 80, and then immediately you print it. Decimal equal to percentile 0.2f comma u dot decimal. Okay. Similarly, you can modify also the third value. So strcpy string copy followed by u dot name. Okay. You can store another string. Okay. Like best college. You can store like this and you can print it immediately. So printf your name is equal to percentile s comma u dot name. Okay. Now let us save and run this program to see the output properly. Now what is the problem over here? That u dot integer, there is a spelling mistake. Okay. Now save and run. Yes. Now you can see that accessing one member at a time in union was not possible. Earlier you got some garbage for integer and decimal value. Only the last member name was stored. Now what I have done, I have modified one member at a time and I am printing. Now integer has got 200, decimal is 80.0 and name is the best college. So in this way, the memory which is allocated to union can be used. So through this example, we have seen how to make use of structure and union members and what is the difference between structure and union really. Okay. Now let us talk about some other examples to understand the structure and union concepts. Okay. Now let us go for hash include stdio.h. Try to understand that we will check what is the output of the program. Find the output of the program. Now let's write the structure of the program. Int main, then return 0. Okay. So what is given in this program? Now in this program, one union is given. Union followed by union name, and the union is having two members, your int I and character ch of 2. Okay. Now let us write union A and create a variable u over here. Now u dot ch of 0, okay, is equal to 3 and u dot ch of 1 is equal to 2. Now print the value of printf percentile d comma percentile d comma percentile d comma u dot ch of 0 comma u dot ch of 1 comma u dot I. So we have written the program. Then what will be the output of this program? So first let us save it. Struct 1, or let us take struct 2 and save it. Now you can see over here we have defined a union, and every member of the union has been given a value. Okay, so except u of I you have not given. Now let us check what is the output. What is the output that you are getting over here? 32515. So ch of 0 we have given a value, ch of 1 we have given a value, but u of I you have not given any value. So by default it is showing some garbage. Okay, so this is the output. Now let us discuss another problem using union. So the question is again, find the output of the code. So we'll start with the header file #include stdio.h int main return 0. Now first declare one union. So it is union. The name of the union is some variable. It has got two variables, int a comma b. Now after declaring the two members, both are integer type, let us put a semicolon over here. So my union declaration is over, and let us create a union variable. Union variable is suppose v. Okay. Now let us assign the values to both the union members. So v dot a is equal to 10 and v dot b is equal to 20. Let us assign the values to both the members and now print it. So if you will print it, percentile d slash n, then we will print v dot a. What is the output? That we will get it over here. Now try to understand over here. We have declared one union and we have declared two members over here, and both the members are having the values. Now what will be the value that is stored finally into the member A? Now first save this union. So save it as a C source file and then run it. So you can check over here that we are getting the output as 20. Why? Because the last value which is stored into that area is nothing but 20. That's why though you have assigned 10 to A, but you will get the output as 20. So please understand this difference in case of a union. But this will not happen if you will change this to a structure. Okay. So if you will change this to a structure, then this problem will not happen. So the latest value which is there in memory, that will be the output. Now let us go for another question. So this question is related to bit fields. So #include stdio.h int main and return 0. Now how to declare the bit fields? Bit fields are declared for the members of the structure. So first let us create a structure. Suppose the name of the structure is value. And what are the members? Suppose int bit1 is one of the member, and for this integer, normally an integer in 32-bit or 64-bit computer, it takes 4 bytes, but for this we want to give only 1 bit. So put a colon and give the number of bits you are trying to allocate. Now second member is also integer. So we want to give this, okay, let us take bit 3 or bit 2 and we will allocate some 3 bits. Okay, now the third member is bit 3 and we are allocating some 4 bits to it. Okay, now for this bit we will give like this. Okay, so 1 comma 2 comma some 13 we have given. Okay, now this is an bit array, so which will contain the values 1, 2 and 13. Right, now let us print these values. So write printf, okay, percentile d comma percentile d comma percentile d. So give proper spacing and print bit is the variable name. So bit is the structure variable name. So bit dot bit 1, then bit dot bit 2 and bit dot bit 3. So here what we have done, we have created a structure and we have initialized some values over here. Okay, now these structures, every member is represented through number of bits, and this bit is nothing but the structure variable, and the first member is assigned with a value 1, second member is assigned with a value 2, and third member is assigned with a value 13. Now let us see these values can be properly stored into those bits or not. Okay, now let us save it. So it is bit filled. This question is related to bit filled. Save it and run it. Now what is the output that you are getting? You can see over here that bit 1 has only 1 bit. Representation is only 1 bit. So the value 1 cannot be stored. Let me copy this and paste it over here. It cannot be stored. Okay, the bit 2 is given 3 bits. Okay, so bit 2 has been stored properly. Okay, because 3 bits means 2 is nothing but 1 0. Okay, so 3 bits is enough for storing this, but the third one has been given the value as 13. Okay, the binary equivalent is a 4-digit number, but you have given exactly 4 digits, but it cannot be stored because 3 bits, 1 bit is reserved for sign. Okay, out of 4 bits, 1 bit is reserved for sign, so it has also contained some garbage. So let us increase these values to suppose 6 bits. Suppose this is okay, and we make it 4, and this is also make it 4 bits. Okay, now save it and run it again. Now you can see that the values 1, 2 and 13 are stored properly. Now these values are stored properly. So whenever you give the number of bits, internally it converts these values into bits, but the 1 bit is reserved for sign bit. So whenever you are trying to save the memory space, so you have to give the number of bits plus 1. Okay, so in this example you understood how to use bit fill concept. Now let us go for next example. Now in the next example, let us modify this. In the bit filled example, suppose I am giving here 1 bit, here 4 bit, and also here 4 bit. Okay, so there are 3 members. Instead of doing initialization, let me check what is the size of this structure. So printf size of the structure is equal to percentile d. Okay, now use the size of. Now for this we need a variable. Let us create a variable called bit and give size of bit. So what will be the size of this structure whenever you are using bit field? Now you can see that the size of this structure, the output you are getting is 4 bytes. The output you are getting is 4 bytes. Now you can see over here that whenever you are giving the number of bits as 4, will it exactly give 4 bits or will it give 1 byte it will assign? Okay. So here the total, earlier the memory requirement was 4, 4 and 4. So it was 12 bytes. But this 12 bytes has been reduced to only 4 bytes. Okay. This way, using bit field concept, you can save the memory. So this is the way you can save the memory using bit field concept. Okay. Next. Now let us go for the next question. Next question that we are going to discuss is on enum. So how to use an enum? Now let us go for the structure of the program first. Suppose enum days, number of days in a week, we are going to write. So we'll write like this. Suppose Monday is equal to -1. Then we have Tuesday. Then we have Wednesday is equal to 6. Then Thursday. Then Friday and Saturday. Suppose the enum is like this. For every enum, we need to create a variable. So enum days, D is the name of the variable. Now, first print the first member, you have to print it. How to print the first member? Or if you want to check all the members' values, so what you have to do? So %d, comma, d dot your Monday. Okay, now let us save it. It is enum type and save it first and then create it. So what is not allowed over here? That the dot operator which we have used is not allowed. So how to print? Let us print simply Monday. So let us check what is the output that you are getting. It is -1. Okay. So we are getting the output here is -1. Okay. Now let us print the value of Thursday over here. Now you know that Wednesday you have changed to 6. So every next member will be added or incremented by 1. So if you check the output, then you will find that the Thursday value is nothing but 7. This way, a union works. In today's video, we have discussed a number of problems related to structures and union, and also we have understood the difference between structure and union. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.